kind of doing, my guess is something like a little factor tree that 4 times 4 will give you 16, but we wanted prime numbers, prime factors that can be broken down to be 2 times 2, and then 2 times 2. And then since these are all prime numbers, you would say the prime factorization of 16 is 2 times 2 times 2 times 2. So when you were told to factor, what you were trying to do is find the simplest terms. In this case, there were a bunch of 2's that would have multiplied to give you the original problem. That's what we're doing. We are factoring. Yeah. What are they then, you're asking? Prime numbers are, so like if I gave you 4, there's 2 different ways I can get a 4. 2 times 2, and then 1 times itself. A prime number is like 3, where there's only one way to get a 3, and that is 1 times itself. That's it. Correct. Not in whole numbers, integers only. Okay. So these are our factors that multiply to be 16. Well, we can do the same thing with trinomials. So what we're trying to figure out is what did we multiply together to give us this trinomial? The way we're going to approach this is we're still going to use our little boxes over here. And I'm going to try to use the word box versus squares because these are not going to be squares anymore. Squares by definition mean the sides are all the same. But we're going to approach this the same way that we would have dealt with some of the problems you just quizzed on. To get the b squared, that's still going to be this upper left-hand corner. And then the only way I can multiply to get a b squared is with a b times a b. All right, so we're going to start with that. The 7. The 7 is always the number, the constant without the variable. That is always the number in the bottom right-hand corner. So that's going to be your 7. If I then ask you what numbers multiply to give you a 7, that's what's got to go right here, right? We always took these 2 locations, multiplied them together. Well, hello, Maria. You're lucky you got a Cubs jersey on. I was going to be angry at you, but I'm going to let this slide a little bit. Oh, I already put it away. This. Did I put what did I do with them? I'm sorry. There you go. All right, so now, if I ask you, so this is kind of Jackson's question a little bit, what's a way to multiply to be 7? Well, 7's a prime number. The only way you can multiply to get a 7 is with a 7 multiplied by a 1. That's it. Now, eventually, if that's not a prime number, it's going to be a little trickier, but that is the only way to multiply to get a 7. Well, then think about what happens in this box right here. If I did this 7 times this b, that should give us a 7b. The bottom left-hand corner is going to be the b times a 1, so that's a 1b. Do those add up to give us the middle term that we have in this original problem? Yeah. So what that tells us is if I took a b plus a 7 and I multiplied it by a b plus a 1, that should give us this original problem. You don't have to do it every time. We're going to do it in this one. Yeah. That's your answer. That's it. Short and sweet. Just bam, you're done. Now, I'm going to do extra work in this one just to kind of show what we're finding so we understand sort of what this whole idea is about. You can show this if you want, but I should now be able to multiply this out. So I'll do this here. B times b would give me b squared. The b times the 1 would be 1b. So you had to do this a little bit on your quiz yesterday. If I then take the 7 and distribute, 7b, and then 7 times 1 to give me a 7. If I now add up these like terms, notice how that does in fact give us the exact problem that we started with. Okay? We agree with that? So that's what we are now trying to find. It's akin to doing it with numbers like we talked about right here, just breaking it down into what numbers did we multiply together to get a 16. Now what we're trying to figure out is what did we multiply together to get this trinomial. All right. All right, so go over to number 2. And kind of the same thought. So now I'm still going to have you draw in these little boxes. at least for today. And then eventually we'll again try and maybe graduate from those. But for right now, draw this in. It's a nice way to organize this information. My pen is not working. There we go. So n squared has to be right here. All right, 10 has to be right there. The way I got an n squared is by taking n times n. So those have to be the locations for the n squared. And then, Henry, how can I get a 10? What do I multiply together, Henry?
Probably 10 times 1 or 5 times 2. Anything times 8 that would be 10.
So you give me one of those. What do you want to go with?
10 times 1.
All right. So Henry says 10 times 1. So do we agree 10 times 1 would in fact give us this bottom right-hand corner 10? Yeah, so far so good. If I now ask you what is this box going to be, 10 times n would give us a 10n. This box would be n times a 1. That would give us a 1n. So I have the n squared. That's this first box. I have a positive 10. That is this box. The middle term needs to be the sum of these two. So when I add these up, do they add up to be a negative 11n? No. Is it close? Yeah, because what do they add up to be? Regular, right? Positive 11n. So Hannah, were you going to tell me how we can correct that? Okay, so good. So what Hannah said is, could we just make both the 10 and the 1 negative? So put negatives in front of those two guys. Does a negative 10 times a negative 1 still give us the 10? Now each of these is going to be a negative, so negative 10n and a negative 1n. Now do these, in fact, add up to give us this middle term? Yeah. So what we have found now is the factors would have been an n minus a 10, and I would have multiplied that. That would have been our length. Our width would have been this n minus a 1. And again, you don't have to show it for all of them. So again, we're not going to go through it all. But if I went ahead and distributed all of this, add up all of your like terms, guaranteed it's going to give you what we started with. Okay. All right. So go to number 3. Hopefully we're starting to see this a little bit. And go ahead and set up your box. M squared has to be here. Negative 90 must be there. So we've taken care of the first term. We've taken care of the last term. M squared can only be gotten by doing m times m. So we know those got to go right there. This one's a little harder because there's a lot of ways to get a 90. 1 and 90, 2 and 45, 3 and 30, 16 and 5. There's a lot of different ways. So what we now need to come up with, I want you to think this one through a little bit, come up with two numbers that multiply to be a negative 90. That's what has to happen. All right. These two spots must multiply to be that. But when we get these two boxes and add them, notice how we just have a little 1 right here? These need to add up to be a 1. All right, so go. See if you can get that. And if you get it really quick, just hang tight a minute. All right, but see if you can come up with that combination of numbers. Yeah, I'll talk to you. As a little heads up, you may need some calculators as we work through these. So if you have your calculator, it would help. We could probably sit here. All right. Anybody think they have that combination of number? I'm gonna go Jackson for this time. 2 solutions. All right. All right. So let's do this. Oops. 3 times negative 30, and let's test that one. So do we agree 3 times a negative 30 gives us this negative 90 like it's supposed to. Yeah, so we're good. So now let's test these. 3 times m is a 3m. The m times a negative 30 is a negative 30m. So now we know this is right if these two guys here add up to give us a positive 1m, do they? All right, do they, Jackson? Okay. So we don't necessarily have two answers. There's just a lot of different combinations to try. That combination just doesn't work. And you're going to pick wrong combinations. That's okay. Do you feel better about your second one? All right. So now James says, let's do a negative 9 and a 10. Negative 9 times 10 will give us the negative 90. So we started off good. The negative 9 times this m makes this box a negative 9m. This box down here would be the 10 multiplied by m. Now if I add these guys up, do they add up to be a positive 1? Yeah. So now James's second one, good. Or Jackson's second one is good. M minus a 9, that's the top one. And m plus a 10, that is your second one. Somebody asked last period, does it matter which order? It doesn't. So if you put the m plus 10 first and the m minus 9 second, that's the same exact thing. So you can put it in either order. All right, doesn't matter. All right. Okay, 4. Try that one. So make your little box. See if we're understanding what we're trying to now find. A number of ways to get a negative 12. The combination that works is the combo that also adds up to be a positive 4. All right, hang on a minute. Okay, I'm actually going to do this one. Juan has it. I would pick on it. But here's what happened last period. And I like how this played out just as you see more of these so you can kind of see what would happen when we do them. So last period, when I asked somebody what they used to get this negative 12, they told me they picked a negative 6 and a positive 2. All right, do we agree a negative 6 times 2 gives us this negative 12? All right, we agree with that. And then what we did is we said, all right, well, let's test it. Negative 6n, positive 2n. And I said, all right, we know this is right if these two numbers here, all right, these two boxes here add up to give us a positive 4n. Do these add up to be a positive 4n? No, they're what? Good. So as long as we get the right number, so we got the right number in 4, all we have to do to quickly, don't erase everything and start from scratch again. All that means we needed to do is switch those numbers around. So make your 6 a positive 6. Make the 2 a negative 2. And then now what should happen is, and if you got it right away, great. But that should now give us a positive 6m, a negative 2n, or n's, I guess. Now do those add up to be that positive 4? So it's just a quick little sign change. And then we have our combination. We have an n plus a 6 times n's and n minus a 2. If we multiply that out, it's going to give you that trinomial. All right. Okay, we get the hang of this a little bit. All right. Do 5 and 6. So go through 5, 6. We'll give you a couple minutes. We'll see if you actually are getting the hang of it. numerator, you still want to do yeah, the final answer that I'm going to be looking for is still that. Or the parentheses multiply. So for all of those, you still have to write that. Yeah, so if you just make sure just write these, that's all two answers like up here. So we had plus 6 parentheses. Doesn't matter. All right. Number 5, most people over here ended up getting it, but they did have to think a little bit harder on this one because I think everybody's first instinct to get a 9 would be a 3 and a 3. So the n squared is going to be here, the 9 is going to go there. And the n squared we can only get by doing an n times an n. Most people right off the bat think 3 and 3, but was there any way to get those combinations to add up to be a negative 10? No, all right, didn't work. So up across the top, what'd you pick, Woodley? What did you pick for this one? Good. But if we pick a negative 9, negative 1, those still multiply to give us a positive 9. Upper right-hand corner box is a negative 9n. The bottom left-hand corner box is a negative 1n. Do those now add up to give us this negative 10 on the inside? Yeah. So then that is our combo. N minus a 1 times an n minus a 9. Somebody asked it again, so just to make sure we're clear. If you put the n minus 9 first and the n minus 1 second, both of those are the exact same thing. Doesn't change anything. You're still good. Yeah, Destiny? No. Yeah, that's fine. So she's saying if we put the negative 9 here and the negative 1 here, that's also fine. Yep. All right. Then letter B, or number 6 with the B's, I would think this is a nice one because probably your first thought for 64. And then the bigger the numbers, it can get a little trickier because 64, just like the 90 that we did up here, there's a lot of ways to get a 90. There's a lot of ways to get 64. So you can use your calculators. We can use our brains. Mr. Kuba is going to also give you a little something that you can work with here. Why did I use it? And it's just a bunch of factors for these. So when you get that, and again, you can use your calculator. Some of us, if I can get my pen to work, can do this without knowing what the factors are. But if you look, there should be the number 64 on that little sheet, and it should have all the different ways you can get a 64. All right. When you look at the 64, find the different combinations then that add up to be a 16. All right. And when we did that, what two numbers multiplied to be 64 but added up to be a 16? Yes, ma'am. Good. 8s. So those are now both 8s. So this would be 8b and an 8b. Add those, you get 16. Multiply them, you're going to get a 64. This is actually what we have been doing, right? Aren't these now perfect? Isn't this a perfect square? Because they're the same on the top as there is on the bottom. We could, if we wanted to, write this one as b plus 8 squared. All right. All right, next ones. So now, if you want to use your little sheet, just so you kind of understand how that sheet would work for us and how it would help. And some of you may need it, some of you may not. M squared, we know goes here. The negative 24, we know goes right there. Let's see. All right, so if you look at your 24 on that sheet, those are all the factors of 24. So it's got to be either the 124, the 212, the 38, or the 46. Those are our combinations that we want to explore. The combination, and then again, understand that it's a negative 24. So the signs do play a little role there. And then we want to make sure that whatever ones we pick, when we add them, they're going to add up to be a positive 2. Do you have it, Kat? Yeah. Oh, hold on just a second. I want people to kind of think it through here a second. All right, Cats. What'd you come up with, Kat? So I have my M here. I have an M here. What numbers did you use to multiply to be that negative 24? Say that one more time. Good. So she picked one as a negative 4, the other as a positive 6. So our first check is, do those multiply to be a negative 24? All right, and they do. And then our second and hopefully our final check is, when we add these terms up, negative 4m and a 6m, when I add those, do they add up to be a positive 2? Yeah. All right. So Cat gives us the m minus a 4, m plus a 6. If I FOIL that out like we did that first one to kind of prove it, it would multiply out to give us that trinomial. Okay. All right, try 8. 8 I consider a little tricky one. Let's see what you think. Because there's a number of ways to get 24. We didn't do this one last period. Yeah, don't work too hard on this. Anybody coming up with this? Okay, good. As we kind of look at this one, in terms of getting a positive 24, you have those factors. Is there any way, any combination that we're coming up with that multiplies to be 24 and will add up to be a negative 4? No. So what this now means, so the way we started this whole thing off is the idea that when I give you a certain number, and the way you would have factored before with numbers is breaking it down into their prime factors, which was 2 times 2 times 2 to get us to 16. If I ask you to do that with a 7, how do we break down a 7? Yeah, 1 times 7. So Jackson asked about it a little bit at the beginning if it's a prime number. If it is a prime number like this, back when you would have done it, your teacher wouldn't have had you factor it. They actually probably would have had you write prime. It's the same thing with these. So if we get to one like number 8 that we cannot factor, we cannot find any two binomials that could be multiplied, it's like a 7 if you're told to factor a 7. It can't be done. So you would just write this as prime. There's nothing we can do with this. Okay? So that does happen. Don't give up though on your combos too quickly. All right, a lot of times people don't get it right away and then like, oh, it's prime, but there is a combination that does eventually work. All right, so when we do this, try 9 and 10. So go through those couple real quick. Let's see where we're at. See if we're getting the hang of this a little bit. These both work, so don't be writing primes down for 9 or 10. These will both work. Also, we're going to add one small layer of this tomorrow. The other thing we're going to do tomorrow is, can we do it without the boxes all the time? So as you start doing these and you start understanding a little bit, if you can graduate from the boxes, that's eventually where we're going to head anyway. What's that? It's a nice visual to see where it's all coming from. Okay, number 9. Let's see where we're at. These guys are over here getting close. So we have our k squared. We have a 40. All right, Riley, what did you pick for number 9? Good. So she picked -5 and -8. A -5 times a -8 gives us 40. And when we get the -5k and a -8k, they give us a -13. So k minus 5, k minus 8. All right, that's our answer. When we came over to number 10, a squared and then an 18. Haley, what'd you think? What two numbers? Let me do my A and A. What multiplied to be 18, but would also add up to be the 11? Good. You said 2 to 9? Yeah, 2 and 9. So that would be 2A. 9A gives us the 11A's that we want. So that's an A plus a 2 times an A plus a 9. That is our guy. Okay. All right. 11, I think, is a little tricky. We'll kind of jump around. Do 11.
Honestly, if there's one at 40.
All right. Anybody got this one? Jose or Juan? Juan.
I got -8.
Good. So he picked a -8, +7. We can check it. -8 times 7 will give us a -56. And then this -8n and the 7n here, when we add those up, will give us this little -1 that's in front of the n. So that is n minus 8, n plus 7. All right, that would be our answer. All right. Let's see here. What's the next one? Let's do one more because I want to get to 15 and 16, but those are a little bit different. Go to 13. We'll finish with 13. Get that combo.
Did you say 13?
Yeah, 13. All right, Mark. Got it, Mark? What do you got? Good. So -2 times a -4 make a +8. The -2 and the -4b's added together will give us this -6. So we just write b minus 2, b minus 4, and then that's our answer. Okay. Bring this tomorrow. If you look at number 5 real quick, notice how 5 is going to now be different. Notice how there's a 2 in front of all of these, or a 5, a 2 again. That's going to change our thinking a little bit. So we'll start up with those tomorrow, and then we should be good, hopefully, with all of this. All right, so no homework. You're free tonight.